Hello students, welcome back to the maths class. In our last class, we have discussed some concepts about surface areas and volumes. We have discussed some examples and we have solved some questions from your book. In today's class, we will discuss some more concepts about surface areas and volumes. So, let us start. Students, let us now solve question number 7, exercise 13.7. It says, a right triangle ABC with sides 5 cm, 12 cm and 13 cm is revolved about the side 12 cm. Find the volume of the solid so obtained. Okay. So, let us solve the question. So, students, when a right angle triangle ABC is revolved about its side 12 cm, a cone with height as 12 cm, radius as 5 cm and slant height as 13 cm will be formed. Okay. So, in that case, for the cone we have h is equal to 12 cm, r, that is our radius, is one of the sides, that is 5 cm, and the slant height is the hypotenuse, that is 13 cm. So, we get these data from the right angle triangle, okay, because it is now the right angle triangle is revolved. So, it is revolved around with a radius of the base, that is 5 centimeters. Now, the base becomes the radius of the base of the cone. The slant height is nothing but the hypotenuse of the right angle triangle, and height, that is 12 centimeter, is fixed. Now, volume is equal to 1 by 3 pi r square h, that is 1 by 3 into 22 by 7 into 5 square into 12. Okay. So, what should we do now? That is 1 by 3 into 22 by 7 into 25 into 12. Okay. So, it becomes 3 4 jar. So, 2200 by 7 centimeter cube. Okay. So, the volume of the cone formed is 2200 by 7 centimeter cube. Students, you can represent this in another way. See, if you substitute 22 by 7 as pi, what it becomes? Pi into 100 centimeter cube, or you can say 100 pi centimeter cube. Okay. So, the volume is found to be 2200 by 7 centimeter cube, or you can represent it as 100 pi centimeter cube. Okay. Hope you understand. So, students, let us now solve question number 8. Okay. It says a right triangle ABC with sides 5 centimeter, 12 centimeter and 13 centimeter is revolved about the side 5 centimeter. Then find the volume of the solid so obtained. Find also the ratio of the volumes of the two solids obtained when we revolve the triangle about side 12 centimeter and side 5 centimeter. Okay. So, let us solve the question. So, students, as per the given data, here radius is 5 centimeter. Fine. So, radius is 5 centimeter, height is 12 centimeter and slant height is 13 centimeter. So, in this case, let us find the volume. In a later stage, we are going to find the ratio. So, let us take the volume as V1 is equal to 1 by 3 pi r square h, or 1 by 3 into 22 by 7 into 5 square into 12, and this becomes 1 by 3 into 22 by 7 into 25 into 12. So, 2200 by 7 centimeter cube, or we can write it as 100 pi centimeter cube. So, volume of the first solid is found to be 100 pi centimeter cube. So, let us find the volume of the other solid that is going to be obtained, okay, when the triangle is revolved about the side 5 centimeter. Okay. So students, when the triangle is revolved about the side 5 centimeter, a right circular cone is formed with radius 12 centimeter. So your height is 5 centimeter and slant height, it remains constant. So let us take the volume to be V2. So V2 is equal to 1 by 3 pi r square h, that is 1 by 3 pi r square means 12 square into 5. So that is 1 by 3 pi 144 into 5, that is equal to 240 pi centimeter cube. Fine. So now let us find the ratio. So students, V1 is equal to 100 pi centimeter cube and V2 is equal to 240 pi centimeter cube. So V1 is to V2 is equal to V1 by V2, that is 100 pi centimeter cube divided by 240 pi centimeter cube. Five by 12, that is 5 is to 12. So the ratio of the volumes is found to be 5 is to 12. Hope you understand. Students, let us now solve question number 9. Okay, it says a heap of wheat is in the form of a cone whose diameter is 10.5 meter and height is 3 meter. Find its volume. The heap is to be covered by canvas to protect it from rain. Find the area of the canvas required. Okay, so let us solve the question. Students, it is given that diameter of the heap is 10.5 meter. So D is equal to 10.5 meter. So R will be 10.5 divided by 2, that is 5.25 meter. Okay. Height is given that 3 meter. So let us find the volume. Volume is equal to 1 by 3 pi r square h, that is 1 by 3 into 22 by 7 into 5.25 square into 3. So that is 22 into 5.25 square divided by 7. So when we calculate, we will come up to a value that will be equal to 86.625 meter cube. Okay. Hence the volume of the heap of wheat is 86.625 meter cube. Now let us find the area of the canvas required. What it should be? It is nothing but the curved surface area of the cone. Okay. So we need to find the curved surface area of the cone. So let us find it out. So students, the curved surface area is nothing but pi RL. So that is equal to 22 by 7 into 5.25 into what is L? L is nothing but the slant height. Okay. So in this case, we can have the value of L as square root of r square plus h square. So we can write it like that. 22 by 7 into 5.25 into square root of r square plus h square. Okay. So here we can see that 22 by 7 into 5.25 into square root of 5.25 square plus h, that is 3 square. Okay. So it gives us a value that is 22 by 7 into 5.25 into 6.05, that will be equal to 99.825 centimeter square. So curved surface area of the particular cone is found to be 99.825 centimeter square. So the canvas that is required should be of area 99.825 centimeter square. Hope you understand the solution for this question. Students, let us now discuss about the volume of a sphere. Okay. Now let us see how to go about measuring the volume of a sphere. First, take 2 or 3 spheres of different radii and a container big enough to be able to put each of the spheres into it, one at a time. Also, take a large trough in which you can place the container. Then fill the container up to the brim with water. You can refer figure 13.30a. Now, carefully place one of the spheres in the container. Some of the water from the container will overflow into the trough in which it is kept. You can refer figure 13.30b. Carefully pour out the water from the trough into a measuring cylinder, that means a graduated cylindrical jar, and measure the water overflowed. You can see figure 13.30c. Suppose the radius of the immersed sphere is r, and you can find the radius by measuring the diameter of the sphere. Then evaluate 4 by 3 pi r cube. What do you find? You will find this value almost equal to the measure of the volume overflowed. Okay? You can repeat this procedure done just now with a different size of sphere. Find the radius r of this sphere and then calculate the value of 4 by 3 pi r cube. Once again, this value is nearly equal to the measure of the volume of the water displaced or overflowed by the sphere. What does this tell us? We know that the volume of the sphere is the same as the measure of the volume of the water displaced by it. By doing this experiment repeatedly with spheres of varying radii, we are getting the same result, namely the volume of a sphere is equal to 4 by 3 pi times the cube of its radius. So, this gives us the idea that volume of sphere is equal to 4 by 3 pi r cube. Okay? And in this case, r is the radius of the sphere. Students, as a hemisphere is half of a sphere, so we can find the volume of hemisphere as half of that of the sphere, that is equal to 2 by 3 pi r cube. So, volume of a hemisphere is equal to 2 by 3 pi times cube of the radius of that particular sphere. Okay? Hope you understood the formula for sphere and hemisphere. Okay? Students, let us now discuss the examples given in your book. Example 17. It says find the volume of a sphere of radius 11.2 centimeter. Let us discuss the solution. So, volume is equal to 4 by 3 pi r cube. Okay. So, radius is given as 11.2 centimeter. That means volume is equal to 4 by 3 into 22 by 7 into 11.2 whole cube. Okay. That is 4 by 3 into 22 by 7 into 11.2 into 11.2 into 11.2. And when we calculate, it gives us a value that is equal to 5887.32 centimeter cube. Fine. Hope you understand. You just need to substitute the value of the radius in the given formula and you can very easily find the volume. Okay. Students, let us now discuss example 18. A shot put is a metallic sphere of radius 4.9 centimeter. If the density of the metal is 7.8 gram per centimeter cube, find the mass of the shot put. Okay. So let us discuss the solution. Since the shot put is a solid sphere made of metal and its mass is equal to the product of its volume and density, we need to find the volume of the sphere. So volume of the sphere, that is equal to 4 by 3 pi r cube. So students, when we substitute the value of r in this formula, we will get 4 by 3 into 22 by 7 into 4.9 cube. That is 4 by 3 into 22 by 7 into 4.9 into 4.9 into 4.9. And when we calculate, we will get a value that will be nearly equal to 493 centimeter cube. That is nearly. Okay. Now, mass of 1 centimeter cube of metal is 7.8 gram. It is given. So, let us find the mass of the shot put. Okay. So, mass of 1 centimeter cube of metal is 7.8 gram. Mass of 1 centimeter cube is equal to 7.8 gram. Fine. So, what should be the mass of the shot put? That is 7.8 into 493. Okay. That is equal to 3845.44 gram. Okay. Or we can say it as 3.84 kg. Okay. Or we can write it as 3.85 kg, because this is an approximate value. Okay. So this is also an approximate value, or you can say this is a nearby value of the mass. Hope you understand. Students, let us now discuss example 19. It says a hemispherical bowl has a radius of 3.5 centimeter. What would be the volume of water it would contain? Okay. So let us discuss the solution. So volume will be 2 by 3 pi r cube. Here radius is given as 3.5 centimeter. So this is equal to 2 by 3 into 22 by 7 into 3.5 cube. So 2 by 3 into 22 by 7 into 3.5 into 3.5 into 3.5, and when we calculate, it will come up to 89.5 centimeter cube. So this is the volume of water the bowl can contain. Hope you understand. Students, let us now discuss exercise 13.8. Okay. Let us now solve question number 1. It says find the volume of a sphere whose radius is 7 centimeter and 0.63 meter. Okay. So let us solve the first bit. Bit number 1. In this case, the radius is 7 centimeter. Okay. So what should be the volume? Volume is equal to 4 by 3 pi r cube. Okay. So that is equal to 4 by 3 into 22 by 7 into 7 cube. That is 4 by 3 into 22 into 49. Okay. So it will give us a value that is equal to 1437.33 centimeter cube. Okay. So this is the volume of the sphere having radius 7 centimeter. Hope you understand. Now let us go for the second bit. Students, for the second bit, the radius is given as 0.63 meter. So r is equal to 0.63 meter. Fine. So volume will be 4 by 3 pi r cube, that is 4 by 3 into 22 by 7 into 0.63 cube, or 4 by 3 into 22 by 7 into 63 by 100 into 63 by 100 into 63 by 100. Okay. And when we calculate, it will give us a value that will be equal to 1.05 meter cube. Hence, the volume of the sphere is 1.05 meter cube, but it is not the exact value, it is approximate value. Okay, hope you understand the solution for question number 1. So students, we have come to the end of today's session, and today we have discussed many concepts about surface areas and volumes, and we have solved some of the questions. Those are given in the exercise of your book. You need to practice all the solution for the given questions of your book so that you can understand all the concepts in a better way. So keep revising, keep practicing and stay safe. Keep smiling. Thank you.